Hi there, welcome to this video. It's 30 days until the first paper of GCSE Maths, and so my target for the next 30 days is to provide a small bite of revision every day until then, on a range of topics. And I guess I don't really have a plan for what I'm going to do every day, but whatever comes to mind, and I'll try and keep it fresh as the time goes on. So today's topic is capture, recapture. What I'm going to do is go through one example, and then I'll show another question. And depending on how much you know, it might be a good idea to, well, you might think, well, I know what capture recapture is, and pause before the first question, and give it a go, and then see if you're right, and then try the second question. If you don't have a Scooby-Doo what I'm talking about, well, just watch my first explanation and then give the second question a go before I go through the solution. Okay, the first question then. So you might want to just pause now and give this a go. But if you don't know what I'm about to do, then just watch. So let's read this question. So a classic capture recapture question is about fish in a pond, and it's usually about estimating a size of a population. So I've got a scientist estimating how many fish are in a pond. She catches some fish on one day, and importantly, she marks them with some sort of tag, and puts them back in the pond. And then the next day, she comes back to the pond, catches some other number of fish, and finds that some fraction of them are marked. Okay, she's found that some number are marked. And we can use that to make a good estimate for how many fish are in the pond. Okay, so let's think about this. So on Thursday, she's caught 180 fish. Okay, so on Thursday, and you don't need to do this label, but I'm just going to write it in. On Thursday, she has caught 180 fish, and that is 180 out of the total number of fish. Okay, so we don't know how many total fish there are, but we know that she's caught 180 out of the total. And then again, you don't need this label I'm about to write in red. On Friday, all of the fish have swum around, and she comes back and catches another lot. She catches 305, and 45 of those are marked. So 45 out of the 180, oh no, the 305 fish that she catches on Friday are marked. Okay, so that's that bit of information. What we're going to do is set these equal to each other. So basically, the way that capture recapture works is we're making the assumption that the fraction that she tagged are equal to the fraction that were tagged on the second day. Okay, what you can do is then you can flip these fractions. Okay, so if I flip them on their head, so I get n over 180 is equal to 305 over 45. Okay, and then what I'm going to do is multiply both sides by 180, and what that does is it clears the fraction on the left. So we get n is equal to the result of 305 divided by 45 times by 180. Okay, now I'll reach my calculator to do that. All right, and then I get 1,220. Now let's just do a reality check on that number. Well, she caught 305 fish on the second day, so clearly there's more than 305 fish in there, and that's the sort of thing we're looking for. There's I'm quite happy that that's not an unreasonable number of fish to be in this pond, maybe more like a lake. And there we go. Okay, so excuse the fact that I've got two B's in this second question. So let's think about the assumptions that we've made. Well, these are fish. It depends what we've marked them with, but basically our assumptions are kind of void if the marks fall off. So if we've sort of got a Sharpie and marked these fish, we're going to hope that doesn't fall off. If we've clipped them with some sort of tag. We don't want those tags to have fallen off. So our marker should not have has not fallen off. Other assumptions, if the fish stay in the same area and haven't sort of mixed up, then that's a problem. So we need to assume that the fish have mixed up in the pond. And maybe the more obvious ones are, in that time, we're hoping that none of the fish have died and none have been born. Okay, so if the population's changed between these two times, that's a problem too. Okay, so the population has not changed, for example, through the fish being born or died, or they've not left the area. So, for example, when we couldn't use this is if we were marking fish on one day, leaving it a year in a river where the fish might have had time to sort of swim away and go elsewhere. Okay, so that's capture recapture. What you might want to do now is pause this video and have another go at this question, and then I'll go through. So here we've got Tom estimating the number of woodlice in his greenhouse. So he catches and marks 32 woodlice. So on the first day, he has caught 32 woodlice out of the total number of woodlice. You don't have to use the number n. N seems to make perfect sense to me, though, as letter to represent a number. And then on the second day, he has caught 20 woodlice and 8 of them are marked. So 8 out of the 20 he catches are marked. We're going to do exactly as we did before. I'm going to flip both of these fractions. So on the left hand side, I've got n over 32 is equal to 20 over 8. Now, you might want to do the same steps as we did in the last question, but for me, I can see there is a clear multiplier between 8 and 32. 8 times 4 is 32. So if I take this fraction on the right and multiply top and bottom by 4, which means it doesn't change the fraction, we get the right hand side as 80 over 32. And on the left hand side, I've got n over 32. Well, if my denominators are equal, then my numerators have to be equal. So in this case, I've got n is 80. Okay, before we accept that as our answer, let's just check. Well, is 80 a reasonable number of woodlice to be in this guy's greenhouse? Well, he caught 32. It definitely needs to be bigger than that. It's not going to be astronomically large. N equals 80. That seems fine. Okay, so that's capture recapture. Hope that's helped with your revision today.